In the first lecture, we have seen the discovery of electrons, protons and neutrons. So different models were proposed to explain the arrangement of subatomic particles inside the atom. These are known as models of atom. In this lecture, we shall see few important models of atom. The first model was given by J.J. Thomson and it is known as Thomson's Model of atom. So let's study about it in detail. In 1898, J.J. Thomson proposed that an atom has spherical shape in which positive charge is uniformly distributed. So he said that an atom has a spherical shape and in that positive charge is uniformly distributed and the electrons are embedded in the sphere. So the negative charge of electrons cancels out the positive charge of sphere. So negative charge of electrons is equal to the positive charge of sphere. So in this way, Thomson's model of atom was successfully able to explain the neutrality of the atom. So it was able to explain why the atom is neutral. This model has many names like the plum pudding model and the watermelon model. But this model also had many drawbacks. This model was challenged by Rutherfords alpha particle scattering experiment. So let's see what is this Rutherfords alpha particle scattering experiment. So in Rutherfords experiment, a stream of high energy alpha particles from a radioactive source was directed at a thin foil of gold metal. So what Rutherford did that he took a thin foil of gold and on that foil he directed a stream of very high energy alpha particles from a radioactive source. You can refer to the diagram of the experiment to understand better. Now the gold foil had a circular zinc sulfide screen around it. Now what this screen did was that whenever alpha particles struck the gold foil and passed through the gold foil, then the point where they touched the zinc sulfide screen, at that point a spark was produced. So when alpha particles touched the zinc sulfide screen, a spark was produced. So in this way, Rutherford came to know that where the alpha particles have touched the screen. So in this way he was able to calculate the deflections of the alpha particles after hitting the screen. So in this way, let's see the observations of Rutherford's experiment. So Rutherford observed that most of the alpha particles pass through the gold foil without getting deflected. This proves that most of the space inside the atom is empty. That's why the alpha particles did not show any deflection. But few alpha particles deflected at small angles. This shows that the positive charge is not uniformly distributed inside the atom. So this proves that Thomson's model of atom is incorrect. Because Thomson's model said that the positive charge is uniformly distributed. But now Rutherford has proven that positive charge is not uniformly distributed inside the atom. This is because few alpha particles were getting deflected. And very few alpha particles rebounded. So this means that the mass and the positive charge of the atom is concentrated in a very small volume inside the atom. And this region is now known as nucleus of the atom. So by these observations, Rutherford came to a conclusion. And his conclusion was the Rutherford's model of atom. So let's see the main features of Rutherford's model of atom. First, the positive charge and most of the mass of the atom was densely concentrated in extremely small region. This very small portion of the atom was called nucleus by Rutherford. The nucleus is surrounded by electrons that move around it with very high speed in circular paths called orbits. So the Rutherford's model of atom was just like the solar system. In solar system, the sun is at the center and planets revolve around it. Similarly, in Rutherford's model, the nucleus was in the center and the electrons were revolving around it in circular paths known as orbits. And the third feature was that electrons and nucleus are held together by electrostatic forces of attraction. So these were the main features of Rutherfords model of atom. Now let's see the drawbacks of Rutherfords model, that why this model failed. So this model was not able to explain Maxwell's theory of electromagnetic radiation. So according to Maxwell's theory of electromagnetic radiation, it said that a charged particle in circular motion emits energy continuously. So whenever a charged particle is moving in a circular motion, in circular orbit, then it will keep on emitting energy continuously. And in this way, it will keep on losing its energy. Thus, an electron revolving around nucleus will also lose energy, because electron is a charged particle and as it is revolving around nucleus, so it is following circular motion. So as it will continue to lose its energy, the orbit of electron will continue to shrink. And finally, the electron will fall into the nucleus. So this means that the electron is very highly unstable and the entire atom will also become very highly unstable. But this doesn't happen. So Rutherford's model was unable to explain the stability of atom, that why the atom is very stable. So this was the major drawback of Rutherford's model. In the next lecture, we shall discuss more about atomic models and we shall discuss that what was the solution of Rutherford's model. So how was his model improved and what all things led to the final model of atom. But before that, we have to learn few important terms. First, atomic number, denoted by Z. Atomic number is equal to number of protons in the nucleus of atom, or atomic number is equal to number of electrons in neutral atom, because in an atom the number of protons is equal to the number of electrons. Second, mass number, denoted by A. Mass number is equals to the number of protons plus number of neutrons in the nucleus of atom. So just the number of protons is equals to atomic number, and number of protons plus number of neutrons is equals to mass number. Now let's discuss how do we represent an element. So for representation of element, the symbol of that element is written in the center. Then on top of that symbol we write the mass number, and on the bottom corner we write the atomic number. So a sample representation would be X, on the top A and on the bottom Z. Now let's solve a question based on atomic number, mass number and representation of atom. So the question says that calculate the number of protons, electrons and neutrons in bromine 8035. This is an NCERT textbook question. So in this question, you can see that the atomic number Z is 35, because the number that is written on the bottom corner is atomic number and the number that is written on the top corner is mass number. So atomic number is equal to 35 and mass number is equal to 80. So as the atomic number is equal to the number of protons, so number of protons is equals to 35. And number of electrons also is equal to the atomic number. So number of electrons also is equal to 35. Now mass number is equal to number of protons plus number of neutrons. So therefore mass number, that is 80, is equals to protons, that is 35, plus number of neutrons. So therefore number of neutrons becomes 80 minus 35, that is 45. So in this way we have calculated the number of protons in this element as 35, number of electrons as 35 and number of neutrons as 45. With this, we have come to the solution of this question. Now let's discuss another very important concept, that is the concept of isotopes and isobars. First, let's understand what are isotopes. So the atoms with same atomic number but different mass number are called isotopes. For example, there are 3 isotopes of hydrogen: protium, deuterium and tritium. In protium, there is protium has mass number of 1 and atomic number of 1. Deuterium also has atomic number of 1 but it has mass number of 2. tritium has atomic number of 1 but mass number of 3. So in this you can see that all of them are having same atomic number but different mass number. Thus they are isotopes. Now let's understand the concept of isobars. So the atoms with same mass number but different atomic number are called isobars. So isobars are just the opposite of isotopes. Now let's understand the example of isobars. So the atoms carbon and nitrogen are isobars. Both of them have the same mass number, that is 14. But they have different atomic number, that is carbon has atomic number of 6 and nitrogen has atomic number of 7. So thus they have same mass number but different atomic number. Such atoms are called isobars. This was all about this lecture. We shall meet in the next lecture. Thank you.